All right, so we're back for video number 5. Topic we're going to discuss now is nitrox. Just a moment. Okay, this topic has to deal with rich air versus regular air or poor air. Of course, this is a joke, but we're going to go over nitrox. Nitrox diving. We're going to look at the many terms used to describe nitrox. We're going to look at both the benefits and hazards of diving with nitrox and nitrogen composition. This is important because as recreational open water divers, you're able to breathe specialized gas to extend your no decompression limit, or NDL, dives. Okay, here we go. All right, what is nitrox? Any gas mixture containing a higher than normal percentage of oxygen and a lower percentage of nitrogen than air. All right, a composition of air is about 21% oxygen, 78% nitrogen, and about 1% other gases, primarily argon. So that's the composition of air, whereas the composition of nitrox is any gas greater than 21% up to 40% oxygen, and the balance of the gas is nitrogen. Nitrox is known by many names: enriched air nitrox, oxygen enriched air, EANX, safe air, EAN32, EAN36, or NOAI1, which is a 32% mix, and the NOAI2, which is a 36% mix. All right, the two main common recreational mixes contain 32% and 36% oxygen. All right, benefits of nitrox. You are absorbing less nitrogen. You have longer no decompression limit dive times. You're at a reduced risk of decompression sickness. Not totally eliminated, just a reduced risk, okay? That's important there. All right. Nitrox reduces required surface interval between dives as you're taking on less nitrogen, so less nitrogen to off gas, and you get longer repetitive dives. Of course, contingent on your sac rate. All right. I got an example here on the right of a repetitive dive profile using air versus using nitrox, 36% mix nitrox. All right, in the air example, dive number 1 went to a depth of 90 feet for 20 minutes. After surfacing a 1-hour surface time, the diver goes from a group F to a group G. The second dive is limited 80 feet for 12-minute no decompression dive, okay? In the next example on nitrox, using the same dive profile from the first dive, same 1-hour surface interval, the diver goes from a group E to a group D diver. All right, now dive number 2 at 80 feet, you're allowed 36 minutes of no stop time. All right, so that nitrox provided a 24-minute, you're able to add 24 more minutes of dive time, no decompression dive time, okay? In the chart here in the center, you could see your no stop dive times, a comparison between 21% air or your 32 or 36% mix. So at looking at a depth of 90 feet on air, you're allowed about 25 minutes, where on 36% nitrox, you're allowed 50 minutes. Again, that's the less nitrogen ungassing rate, okay? So those are your differences there. All right, now looking at partial pressure, I had a similar chart when we were talking about dive physics. So dive physics, still comes into play with nitrox diving, all right? Partial pressure, it's effect of a single gas component in a gas mixture. So now if we're looking at nitrox, now you're saying, say a 30% mix of oxygen and the remaining mix of nitrogen, all right? Still the same applies as far as Dalton's law goes. The total pressure of gas is equal to the partial pressure of gas 1 plus the partial pressure of gas 2 up to the partial pressure of the nth gas. And another way to write that formula is the partial pressure of a gas is equal to the fraction of that gas times the total pressure. So I can essentially replace my numbers here for air and relate that to nitrox, for the still sum to be, your total absolute pressure, okay? All right, so what is narcosis? Narcosis is a numbing or state of stupor, almost a state of euphoria, where it slows down information processing. It affects most people in the 100-foot to 130-foot range at depth. Dangers of narcosis is unable to deal with problems and difficulty in managing multiple tasks. I'm sure we've all heard about a diver actually spitting out their second stage because they're narked. Another term is narked. Okay. Hazards of nitrox. It's not a safer gas than compressed air in all respects because you're dealing with, because of not oxygen, you're dealing with an increased risk of fire. You're also dealing with an increased risk of oxygen toxicity. It affects the central nervous system and taking on too much oxygen at depth. So you do have your actual depth limits when dealing with different mixtures of nitrox. All right, myths of enriched air nitrox. Nitrox is safer than air. That's a myth. Nitrox is for deep diving. That's a myth. As a matter of fact, the more percentage of oxygen that you take on, the shallower you have to go, okay? You can't get decompression sickness. That's a myth. It reduces the risk of decompression sickness, but it doesn't eliminate it, okay? Narcosis is eliminated. There's actually no studies to show that there's more or less of an effect of being narked with air versus nitrox, okay? And then using enriched air nitrox is difficult. Actually not, it's about relatively the same as air. Okay, in summary, so we went over enriched air nitrox diving to include the benefits, hazards, and myths. We saw some examples, again, of partial pressures. We reviewed definition and effects of narcosis. And as an aside, NAUI actually recognizes enriched air nitrox diving and has a comprehensive program available to properly train divers in its use. So there's an actual nitrox course that NAUI has, for that NAUI nitrox certification. Thanks for looking. Thanks for looking and listening. Bye-bye.